an example of how to come up with an approximate chemical shift value for a molecule of interest. So let's say that you've done a condensation of nitromethane with ethyl acetate, for example, and you want to know if this is the material that you've actually made. Pretty simplistic example, because if you wanted this, you could just buy this. But let's work through it anyway. Okay, so where would our likely chemical shifts appear for this kind of structure? Well, we've got a methyl ketone on the left-hand side of this molecule. And so you can either look up in your book where a CH3 next to a ketone appears. Here's our RCOCH3. The table tells you that it's 2.2 parts per million. Or, like I said, you can remember that acetone appears at about 2.1 or 2.05 or 2.2 parts per million, depending on which solvent you're working in. Okay. Either way, you're probably going to come up with an estimate for this methyl group of about 2.2 parts per million. Okay. What about the methylene in the middle? Well, if you think of your common NMR impurities, hexanes is one of them. Right? Hexane's ethyl acetate you use to run your column, so you know where the ethyl acetate appears. You should also have an idea of where the hexanes appears. Okay, so let's just go and look at that. So here's N-hexane. Okay, the CH2 in N-hexane is sort of at about 1.3 or thereabouts. Similarly, in your NMR table, you'll find that a sort of methylene with nothing else very interesting nearby it, the default value for that is about 1.4 parts per million. So let's take 1.3 or 1.4 parts per million as our base value for a methylene. Okay. You know that a methylene next to a carbonyl appears in the NMR at about 2.4 parts per million. Okay, you can look that up in the table, or you can determine what that might likely be from acetone. And so you might say, therefore, that that carbonyl is worth an extra 1 part per million, roughly speaking. Okay. Similarly, you know that a methylene next to a nitro group appears at about 4.4 parts per million. You can either derive that from the chemical shift value for nitromethane, or you can get that from your additivity table. Okay? So if this CH2 attached to a nitro group is worth 4.4 parts per million, we add a carbonyl, we're going to be adding an extra 1 part per million, roughly speaking. Okay? And so we might estimate that this methylene would appear in our NMR at about 5.4 parts per million from this very simplistic kind of additivity calculation. Okay? It's just an estimate. We don't expect it to be that accurate. But it's good to have a number in mind when you go to look at your NMR. Okay? We might say 5.4 parts per million. In fact, the actual chemical shift in chloroform is 5.3 parts per million. It's pretty close. And the chemical shift for the methyl group next to the ketone is 2.33 parts per million in chloroform. So these very, very simplistic estimates actually do a decent job of predicting the approximate chemical shifts of a molecule of interest. Okay? Does everybody kind of see how the numbers, where I'm pulling the numbers from? Okay, I'm being very, very rough and very hand-wavy, but that's useful in terms of allowing you to very, very quickly assess the properties that the proton NMR is telling you. Okay? Now let's have you guys work through it.